Okay. Thank you. Hi, everyone. My name is David. This is actually my first Kai talk ever, so we'll see how that goes. So yeah, I'm super excited. I'm from the University of Calgary. I'm doing my PhD over there, and I'm going to talk to you about my work that I did at Autodesk Research last year, which is called Pineal, Bringing Passive Objects to Life with Embedded Mobile Devices. So this work was a collaboration between myself, Fraser Anderson, Ryan Schmidt, Lora Oehlberg, Saul Greenberg, and Tovi Grossman. Now, if there's one thing that I want you to take away from this talk, is that Pineal allows people to use mobile devices and their built-in inputs and outputs to prototype new smart objects out of fabricated passive objects. So I just mentioned smart interactive objects. What do I mean by that? Essentially, we have all these different devices that are a part of an everyday life. And we have things like appliances, like this alarm clock that you see here. We have toys that you can maybe like press a button on a car and it'll flash lights and make sounds. We have interconnected devices more recently, so things like these light bulbs that you can actually control with your smartphone. And we also have personal digital assistants like the Amazon Echo, where you can order things online or ask questions. Now, the reality of this is that prototyping these smart interactive objects is actually quite difficult. And there's a reason for it. There's all these different components that are somewhat interconnected. And essentially, we're talking about things like electronic circuitry and having to put these together. So assemble a circuit, solder things. Then you have to program that and make those behaviors work, debug both the circuit and the programming. And then somehow you have to like manage to jam all those circuits and all those wires inside of a meaningful form. So in our work, we use mobile devices to, as an alternative to electronic circuits. And we use visual programming to simplify the programming process, and we automatically generate 3D models. And so this work actually builds on a lot of previous work, mainly in terms of like adding tangibility to mobile devices, so things like slab widgets or Fabricate, where you can actually 3D print conductive objects, or clip-on gadgets, where you can add physical buttons to your phone. There's also a lot of work on automated CAD generation. So essentially, we're talking about things like retrofab, where you can retrofit all the appliances to be interconnected and part of the web by modifying and adding electronic circuitry to it. We can also use things like maker's marks, where you build a sculpture and then tag it to make it functional, or have some sort of like authoring environment in mixed reality like Mixad. And of course, there's work by Valkyrie Savage and colleagues that looked at sensing techniques for prototyping, like, for example, using the camera image or extending the area where you can interact with a phone or any other object by using capacitive material. So our goal with this work is to use mobile devices and their built-in inputs and outputs to prototype new smart objects. Now, when I say mobile device, I mean things like smartwatches or smartphones. They're just about the same, right? So here's an example. Here you have a fire truck that actually flashes lights in different colors. And when you press the button, it starts that flashing. And also it plays a siren sound, which I muted so I can talk to you guys and you don't hear this weird siren behind me. So it looks something like this. You have the top, the bottom of the pieces. You have a mobile device inside of it. You have a button, and you have these light pipes, which I'll get to in a second. So conceptually, what this means is what we call soul body prototyping. And essentially, it's a metaphor. So what do I mean by that? You have a phone, and all of the inputs and outputs that are equipped with it, and the ability to connect to the internet. You have a passive object. And essentially, you have a soul, which specifies the interactivity of the object, and you have the body, which is a temporary enclosure that gives meaning to that object. So essentially, the way that we can think about it is we have this fire truck, but also we have an input modifier, so a way to have tactile input that gets converted into a capacitive signal. And we have an output modifier, which in this case is a tube where we put fiber optic cables to reroute the light from any point in the display to that location within the model. And so if I were to give you guys an indication of what this design space looks like, it's something like this. We have mobile inputs, so things like motion sensing. We have also microphone data, video data, and so on. We have outputs, so things like the display, the audio, and so on. We have connectivity and power, so the ability to connect to the internet and also get the battery and everything all packed into one object, and access to a lot of APIs that would be really hard to do with electronics. And the input and output modifiers, which I just talked about. So we realized this through Pineal. So essentially we have on one side a visual programming environment, and on the other side a 3D modeling environment. And when you modify things in the visual programming, we also send specifications to modify the 3D model to fit the mobile device and expose the inputs and outputs. So let's go through a very simple example. In this case, it's a magic 8-ball. And it looks something like this. Every time you shake it, you get a different answer. So something like try again, yes, no, and so on. The way it works is you go on your tool and you import a 3D model that you either create yourself or you import from the web. And then you specify the interactive behavior. So in this case, you create a shake module that looks at when you're shaking the device, and then you create a text group which tells the system that we need a display to render the text. And we enter a bunch of options like yes, no, maybe, try again, and never. And we randomize that. So now the system knows that we have to place the screen, so the user can place the screen anywhere. And then the system will automatically modify the behavior to create the cavity for a smartwatch and show the display. So all you have to do now is 3D print the two pieces and then put your watch inside of it, as you'll see in like a second, like right there. And then it's just fully functional. So another example that I'll give you is a fire truck toy. So it looks something like this. You first import the 3D model. Then you want to author different interactive behaviors. So in this case, we have two lights that are going to be changing colors. And so we want to alternate between different colors. And those colors are triggered by a timer. So every time the timer ticks, we alternate from one color to the other. And that timer is triggered by a button. And we can also play a sound, in this case a siren, which is from a library of custom sounds. So then we guide the modeling process. So it looks something like this. It first does some automatic tasks, which is splitting the model in half and creating the cavity for the device. And then we can add the different lights. And so when you add the lights, it creates a tubular cavity that goes straight to the display. And then we can add the button, which basically extracts the geometry and separates it so you can print it in conductive material. So all you have to do now is essentially do the fabrication and assembly. So what you do is you put the light pipes to reroute the light from the display and cut it nicely so it fits, and it looks something like that. And then you can use a capacitive printed button to reroute the touch event. But also we can add a squishy spring to make it feel better. And so now it's only a matter of trying it out. So it looks something like this, where you press the button and the lights flash. It also plays the siren sound, by the way. So how does it work? So the architecture looks something like this. I won't get too much into it because of time issues. But we have a visual programming environment where we didn't implement a full-featured programming environment, but we try to abstract as many things of the Soul body prototyping as possible. We have live streaming that goes constantly between the mobile device and the server and the application itself. And we have model configuration. So this is what the model configuration looks like. And essentially, you can do things like position the screen. We can then create a cavity for it that basically starts subtracting the geometry to show the display. And we can similarly add different alignment pins. We can also extract and create holes for different sensors, so things like the speaker or the camera, the microphone, and so on. And we can create buttons as well. So in this case, you will draw any geometry on top of the display, and then it'll extract the geometry and separate it for you and create the spring. To do LED simulation, then what you do is you specify any point, and then you can extract the pipe geometry. We also have the option of a light diffuser, and essentially what it does is we can import a new model that gets printed in transparent material, which then acts as light diffuser. Now, going back to the fire truck example, essentially when somebody programs a task like this, it looks something like that. You have split the model in half, place light number 1, place light number 2, and then create the button, and then it'll do something like this, where it splits the model, creates the cavity, adds the pipe, and then the button. So we also created a bunch of prototypes to just show what's possible with Pineal. I already talked about 2 of them. There's 3 more, which I'll talk about now. One of them is a level. So essentially the idea is as you move from side to side, the bubble in the middle will move until you're leveled and then it's centered, and it vibrates to indicate that you're within 20 degrees. We also have a voice-activated light bulb, and what's interesting is that because we have access to things like the Google Voice API, we can do speech recognition really easily and change the color of light. And in fact, we actually managed to get up to 8 colors working. So you can say things like red, green, yellow, white, off, and then it'll change. Similarly, we have an ambient planter. So this is very similar to the previous example. But the main difference is that it subscribes to a Twitter feed, so in this case a hashtag, and every time you get a new tweet, it'll change color. Now, of course, all of these different prototypes actually go back to our design space. So they're trying to showcase different parts of it, and I encourage you guys to read the paper to find out more. So there's a lot of work that we can do in the future. In particular, I think permanence is one thing that is really interesting. So being able to use old mobile devices and keep them permanently, fully featuring the visual programming, going beyond current limitations of mobile devices. So eventually, maybe there are newer forms of inputs and outputs that we can use, having more platforms that work, and having a user evaluation that lets us really see what it's like to use this platform and the workflow that it provides. So I realize I've told you a lot of stuff, but basically, if I were to summarize that in a couple seconds, I talked about smart interactive objects and how they're ubiquitous but hard to prototype, and how a mobile device can actually encompass a lot of functionality for it. I talked about the Soul body prototyping paradigm to extend the capabilities of those devices to create new objects, and how we realized that through Pineal, which has visual programming and automatic generation of 3D models to fit the mobile device and expose the inputs and outputs. And I showed 5 different prototypes that demonstrate what's possible with the tool. So again, if there's one thing that I want you to take away from this, is that Pineal allows people to use mobile devices and their built-in inputs and outputs to prototype new smart objects out of fabricated passive objects. Thank you.
Hi, Gerard Laput, Carnegie Mellon University.
Hi.
Really good work. I'm really inspired with this type of repurposing of different devices. So one quick question. You've probably thought more about this than I do. Do you imagine this as a tool for rapid prototyping, or is it a tool for actually making like final end products? Like, where in that spectrum do you think this work falls in?
So definitely not for products the way it is right now. I think that is definitely a rapid prototyping tool, and especially because the mobile devices only let you do so much. Sorry, 1 second. Yeah, so because the mobile devices only let you do so much, you can only create things that go around that mobile device. So if you want to do something more complex, then maybe it's not possible. Does that answer your question?
Yeah, thank you.
Thanks.
Hi, can you get a parametric model back out of this so you can continue to do CAD improvements, or do you get just
yeah, so basically what you get is a file in Mesh Mixer. So it's like an OBJ file that you can modify in any way.
Okay, cool.
Yeah,
Thank you.
Thanks.
Hey, Daniel Ashbrook, Rochester Institute of Technology. I really love this, and I think it's super cool. I'm wondering if you've thought about how you might be able to do the design actually in situ. So right now you've got to do all this design on the screen, and then you're building a physical thing. I'm wondering if you've thought about actually doing the design and programming in the physical world.
Right, so for this case, the reason we used visual programming was because we can actually specify instructions really easily for the 3D modeling. I'm not sure what the best way of doing that in the physical world is, but I think that's definitely an interesting avenue to go for.
Hi, I think it's very smart to use already smart object to design personalized smart object. It's kind of meta question. What is the future like for DIY smart object? Do you have any advice for next Kai or next 5 years Kai?
I don't know what the future holds for smart objects, but I think it would be super cool if it was super easy for anybody to just get started and create anything without having to know much. So like they can just realize their ideas as easy as possible. So yeah, thank you.